we'll go from there. All right, so our first one, chapter test practice, chapter 11. We're going to break down that 250 into a perfect square, carrying the 2 in the front. So that's 25 and 10. The square root of 25 is 5. Square root of 10. So we get 10 root 10. So it's got to be a perfect square times what's left over. Obviously, that answer is B. Number 2. We break it into a perfect square times what's left over. 4 times 3 gives you 12. C squared is the even number below a cube, and D squared is already a perfect square. So we take the square root of 4, which is 2. We cut C squared in half. We cut D squared in half. Carry on the 3C root and combine them to get 4CD root 3C. Which of our answers is that? Looks like option D. All right, example 3. We combine the outsides, which is 2, and what's this blank outside out front? A 1. So we combine the outsides and get 2. We combine the insides and get 45. We break the 45 down into a perfect square. What perfect square goes into 45, team? 9. Thank you, Joe. That was Joe Schaefer, everyone, famous mathematician. So 6 squared is a 5. Option C. All right, number 4, getting into the fractions. When we have a fraction in a radical, we have to get the radical out of the bottom. So we try to break it up into 2 parts. In this case, the square root of 49 is 7, and m to the 4th is an even exponent, so we just cut that in half. Boom. That would be the easiest kind that we're going to bump into. All right, down to number 5. Here we have a radical in the bottom that's not a perfect square. And so, Gabby, what I'm going to do here is I'm going to multiply by the square root of 6 over the square root of 6 and do what's called rationalizing the denominator. Rationalizing means you get the square root to be gone. Now, that gives me 3 squared to 6 over the square root of 36. We wanted Eli to have a perfect square in the bottom, and we do, which leads me to my final answer of 3 squared to 6 over 6. Now, I look down at the bottom, and I don't see that answer there, and I think, okay, now wait a minute. I think I did that right. I must have missed something. Well, on a very rare occasion, the 2 numbers that are left outside cancel. In this case, do the 3 and the 6 cancel? They do. So they cancel, and the 3 becomes a 1, the 6 becomes a 2, and is that answer down there at the bottom? It sure is. So if you get a problem where you don't see the answer at the bottom, a little trick, Grace, is you might say, hey, maybe I need to simplify further. So that's a little trick to look for that. All right, Pythagorean theorem. Logan, what is the Pythagorean theorem? Okay, if you don't have your calculator out, you probably want to get that out. Please bring a calculator to the test tomorrow. Please do not ask to borrow one. So we're going to say 7 squared plus 10 squared equals c squared. 49 plus 100 equals c squared. 149 equals c squared. What do we do to solve this? Take the square root. Remember, that's the same as raising it to a power of 0.5. And I get an answer of 12.206. Looks like that's option D. All right, to determine if something is a right triangle, we use the Pythagorean theorem again. 7 squared, 12 squared, 13 squared. I ran out of space there. 49 plus 144 equals 169. 49 plus 144. Does 193 equal 169? No. So obviously, what is the answer? No. It is not a right triangle. Find the distance from H to K using these 2 points. There are 2 ways to do this problem. I'm going to show you both. The first way is by using the distance formula. I'm going to label that x1 and y1, that x2 and that y2. Let's write down the distance formula. Who remembers the distance formula from yesterday? Go ahead. Haley?
D equals the square root of
x2 minus x1 squared, good, plus
y2 minus, no.
Yeah.
Minus y1.
Yeah, y2 minus y1 squared. So here we go. So D equals the square root of 3 minus negative 4 squared plus 4 minus 2 squared. So that's 7 squared plus 2 squared. That's 49 plus 4. So that's the square root of 53. Is that one of our answers? 53 is one of our answers. Do I choose option C? Yeah, take the square root of 53. 7.3. Okay. So be careful that you don't just choose 53. So that's method 1. Some people like this method. Since I gave you a graph, they like to draw a triangle. And they count the boxes. 2 boxes there. 1, 2, 3, 4, 5, 6, 7 boxes there. And they use the Pythagorean theorem. A squared plus B squared equals C squared. And they say 2 squared plus 7 squared equals C squared. 4 plus 49 equals C squared. 53 equals C squared. So it's the square root of 53, which we learned was 7.2. So you have a visual graphic method or you have an algebraic method. It doesn't matter. Now the only time you can use the visual method is if I give you, Maddie, a graph. But I might not. Remember though what Haley told us for the distance formula. I think it would be very, 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 very crucial that you have this distance formula memorized and on your study guide in preparation for the final. All right, now, second question from this section, the midpoint. Somebody else, give me the formula for midpoint. Who remembers it? My midpoint formula. Do you remember what it is? Hadley, do you remember?
x2 plus x1 over 2 and y2 plus y1
Okay. So we add the x's, we add the y's, and go over 2. So here we go. Negative 1 plus 7 over 2. Negative 10 plus 8 over 2. That leads us to 6 over 2, negative 2 over 2. That leads us to 3 comma negative 1. Is that one of our options? Thank goodness it's option D. So, let's say it together. Distance you subtract, midpoint you add. Ready? Distance you subtract, midpoint you add. Remember that for tomorrow. All right, question 10. Simplify the expression. You may only simplify if the radicand is the same. So here they are the same, so we get 5 square roots of 3. You don't get 5 square roots of 6, you get 5 square roots of 3, because you don't change the radicand. Question 11. To simplify this, we must convince this problem to change. So we change that 20 into 4 and 5. Why did I choose 4? Because, Joseph, it's a perfect square. So I have 3 radical 5 minus 6 radical 5. Where did that 6 come from? Did I just write it? Square root of 4 times the 3. So my answer is negative 3 radical 5. Let's see, is that one of my choices? option B. So far, so good? All right, now we need to FOIL. What do you see about problem 12 that's nice? Do you remember what these two are called? Starts with a C. Conjugates. So let's FOIL here. 2 times 2 is 4. Outside, minus 2 root 7. Inside, plus 2 root 7. Back, or last, minus root 49. The middle two terms cancel out. We're left with 4 minus 7, which is an answer of -3. Super simple because they are conjugates and the middle two terms cancel out. Number 13, we're asked to distribute by simplifying. So 14 times 6, you could use your calculator and you could see that that was 84, minus 7 root 14. Now, 84 I know is 4 times 21. And the square root of 4 is 2. And now we look at our problem and say, hey, can you combine those two? Can you combine the square root of 21 with the square root of 14? No. Definitely not. So that's my answer, just like that. But I want you to realize some of these answers. Look at option B. Guys, look at this option B. Did we get option B in the course of the problem? Yeah, we did. So make sure after you multiply, Gabby, that you simplify further if possible. Option B is not the right answer. Option A is the right answer. Making sure that we don't make those mistakes. Now I want to zoom back to problem 12. Christine told us that those were conjugates. And you remember, Bo, conjugates cancel out radicals. So we come down here to 14. To cancel out the radical, we're going to multiply, folks, by the conjugate. So the square root of 7 plus the square root of 3. Here we go. On the top, 5 square roots of 7 plus 5 square roots of 3. On the bottom, what's the square root of 7 times the square root of 7? Square root of 49, which will be 7, plus the square root of 21, minus the square root of 21, minus the square root of 9. Now, that simplifies a whole lot. The top stays the same, but the bottom becomes 7 minus 3. Because, Andy, those middle two radicals drop out. Giving me an answer of 5 square root of 7 plus 5 square root of 3 all over 4. Now, I want you to focus on these 3 spots that I've highlighted in yellow. Are those 3 numbers having anything in common that you could cancel? If they had happened to be maybe 6, 6, and 4, then you could cancel a 2. But in this case, they don't have anything in common, and so that's my answer. Which option is that? Option D? Okay. There we go. Let's go on to 15. Solving equations. When we solve an equation, I think I would put a note at the top that says isolate the radical. So let's add 10 and get 12 equals the square root of q. Once the radical is isolated, we can square both sides. And I've said this a number of times this chapter. When you square a square root, everybody, you get what's inside. So that means 144 equals q. If we plugged it back in, we could see that it works. 16. On 16, the radical is already isolated, so we can square both sides. So h plus 5 equals 36, and we solve that by subtracting 5 and get 31. On 17, we have two square roots, one on each side of the equation. So to solve 17, you square both sides. X plus 8 squared and the square root of 2x minus 1 squared. That gives us just x plus 8 equals 2x minus 1. We solve that. I'm going to subtract x from both sides. Then I'm going to add 1 to both sides, and I get x equals 9. Sure enough, that's one of my options. (18). We square both sides, and we get x squared equals 2x plus 35. We set it equal to 0 by subtracting. Now we factor x minus 7, x plus 5, and we solve, so x equals 7 and x equals negative 5. Now it's interesting on this one, it gives you, it says, identify any extraneous solutions. That's a little bit of a hint. What is an extraneous solution? It's an answer that what? Does not work when you plug it back in. So, I have a little bit more space on this problem, so I'm going to draw 2 lines down here, and I'm going to go to the original problem, and I'm going to try the value 7. 7 equals 2 times 7, which is 14, plus 35. 7 equals square root of 49. Is that true? Yeah. So is that an extraneous solution? If it works, it's a solution. If it doesn't work, it's extraneous. So is this extraneous? No. All right, let's try the other one. Negative 5 equals negative 10 plus 35. Negative 5 equals the square root of 25. Negative 5 equals 5. That is not true. Okay? So this value is extraneous. So the only solution is 7. So let's find which of those options is at the bottom. Option C. So when you see the question that says find extraneous solutions, Gabby, you've got to make sure you plug your answers in to see which one works and which one doesn't. Does that make sense, guys? Extraneous solutions are numbers that don't work. All right, back to our calculators. Everyone remember, your calculators need to be set to degrees, not radians. So punch in the tangent of 48 degrees and tell me what you get. 1.1106125. Which one is that? Option A. Okay. Make sure you can use your calculator and you get that right now with that problem. All right, problem 20. Find the value of x to the nearest tenth. Let's label our sides compared to this corner. What word goes with x? That is hypotenuse, so let's write hypotenuse there. What word goes with 8? Adjacent. Just for the record, this would be opposite. We're not using opposite, we're using adjacent and hypotenuse. So I'm going to write that funny word on the side. So, ka, toa. We have adjacent and hypotenuse. Which function is that? That's ka. What does ka stand for? Cosine. So the cosine of 41 equals 8 over x. Remember from what we talked about the other day, Grace, when the variable's on the bottom, you cross multiply. So x times the cosine of 41, which I'm typing in my calculator, which is 7547 equals 8. And to solve this, I'm going to divide both sides by 0.7547. So 8 divided by 0.7547 gives me 10.6. And there we go, 10.6. Now, I just want to show you. Look at option B. Is there any way that option B could be the answer? No, because distance can't be negative. True? So you throw out option B. All right, problem 21. We're going to have to draw a picture here. Suppose you live 4.9 miles from a hill. So here you are. 4.9 miles from a hill. You see a plane above the hill. Plane. Above means directly above, Isabel. Directly above, so that's your right angle. The angle of elevation to the plane is 27 degrees. Do you guys understand elevation means going up? So put your arm straight out. That's the ground. Now point at the plane with your finger. Okay? Where did your arm go? That's the angle. So put the angle in right there. Point at the hill, then point at the plane. So let's do words here. Find the plane's altitude, and I told you that is the height it is above the ground. So let's do some labeling. This red zigzag line, what word? Is it hypotenuse, opposite, or adjacent? That's opposite. This horizontal line down here, this blue zigzag line, what word is that? That's adjacent. Let's go back to our SOHCAHTOA. What function uses opposite and adjacent? Tangent. Okay? So let's write this down. Tangent of 27 degrees equals opposite, I'm going to call that P for plane, over 4.9. Let's plug tangent into our calculator. 27 degrees. 0.509 equals P over 4.9. How do I solve this? Yeah, multiply by 4.9. I get 2.496. So which is my answer? 2.5? Let's practice one more like that. A ranger spots a forest fire while he's sitting on an observation tower. Okay, so here's our observation tower. I don't know if you've ever climbed a fire tower. They're kind of fun. So he sees a forest fire down here. Here's little Jimmy making his little fire. There's smoke going up. The ranger looks down, right? So here's the ranger. He's searching. Put your arm straight out like you're looking on the horizon. Now, move your arm down to the fire. That is the angle of depression. So you draw a picture like this. Here's your right angle. Our angle of depression is 29 degrees. How tall is his tower? 40 meters tall. By the way, that's pretty tall. That's taller than the field house. So he's way up there on top of a hill. I want to find out how far along the ground he has to run to go. Now that's the same thing as this distance up here. So I'm just going to kind of highlight that in green. What is the green squiggly line with relationship to the angle? Is it adjacent, opposite, or hypotenuse? It's adjacent. Okay, that's adjacent. This one is opposite. So what function do we use with opposite and adjacent? Tangent. So tangent of 29 equals 40 over adjacent. I'm going to call it A. So plug in and do the tangent of 29, and you get 0.554 equals 40 over A. We've done this once already. When the variable's in the bottom, do you remember what we do? Cross multiply. So 0.554a equals 40. So I'm going to say 40 divided by 0.554. The ranger has to run 72.2 meters to find little Jimmy and tell him he shouldn't have fires in the forest. You can save a forest fire. Isn't that what Ranger Rick says or something? All right, let's look at our last couple. Everybody circle B. Circle B. Do you remember SOHCAHTOA? How do you spell SOHCAHTOA? S-O-H. Okay, there's my fraction. What number is opposite B? 35. What number is hypotenuse to B? 37. So what is my answer? 35 over 37. Okay. We ended up with some radicals. What's the square root of 144? 12 and 25. Looks like a hard problem, Bo, but actually it's not. Because you could divide 400 by 5 and get 80. Now, 80 isn't one of my answers, unfortunately. But can you realize that 80 breaks down into 16 times 5? And what's the square root of 16? 4. So that's option A. So, Pythagorean theorem here, right? Logan gave it to us. A squared plus B squared equals C squared. 10 squared plus B squared equals 20 squared. 100 plus B squared equals 400. B squared equals 300. Pop my calculator. 300 square root 17.3. Boom.
Can you go back to 25?
Sure. Took the square root after we canceled, reduced, and then took the square root of 16. I'll upload all these, Logan, as well. All right, let's circle our angle. Compared to our angle, what word is the number 6? Is it adjacent? Is it opposite? It's adjacent. So I'm going to put an A there. What word is x? Opposite. So what function uses opposite and adjacent? Tangent. So tangent of 57 equals x over 6. Take tangent of 57 on your calculator. 1.539. How do I solve this? Just multiply by 6. 9.239. Looks like that's option C. Okay? Airplane over the Pacific Ocean. Okay, here's my little plane. Forgive my drawing. Okay? Do you guys know what an atoll is? It's an island in the water. So here he is. He's flying, and he has a 13-degree angle of depression. He's 648 feet or meters above the water. How many kilometers is it away? So he wants to find this value x. What word is x? Is it adjacent, or is it opposite, or is it hypotenuse? It's the distance that he's flying, right? He's not flying down to the island. He's just flying over the island. And so that is adjacent. Okay? So we have adjacent and opposite. So the tangent of 13 degrees equals opposite over adjacent. Tangent of 13 degrees, 0.23, 648 over x, cross multiply. Once again, we've done this a bunch. Divide 648 by 0.23, and I get 2817. Now, question, is it option A, and did we make a rounding error, or option B?
B.
Yeah, because this is an answer in meters, and to change it into kilometers, it becomes 2.18 kilometers, so option B. That's just a little one where you have to be careful, Sam, with the units of measure. That's all. All right, and that kind of takes us through. So I'm going to upload this, all these work, to kind of help you know what to do there. So we'll save this, and I will upload all of this as well. And what I'd like you to do tonight is the practice test version 2. It took a little bit longer because we were working through it all, but hopefully that was helpful.
And are we to